Today we're looking at the paper, To What Extent Do Human Explanations of Model Behavior Align with Actual Model Behavior, by authors from Johns Hopkins University, UNC Chapel Hill, and Facebook AI Research. This paper is about model interpretability of some state-of-the-art transformer models such as BERT, RoBERTa, ELECTRA, and various later variants that were invented. Model interpretability is growing in importance in the last years, as we would like to be able to understand what the models are precisely doing in the background to come up with their predictions. Transparency is gaining importance. And in this paper, the authors come up with a new way to quantify the alignment, or whether the predictions of the model and the way the models are working internally, whether that is aligned with human expectations or not, and to what extent. The authors come up with a measure about this alignment. Basically, they're using a natural language inference dataset, and they are quantifying the importance of each of the tokens in the input to come up with the final prediction. For example, here we have a document which is about doing natural language inference on some recipe document. Basically, you are provided some recipe text and then some separator token and then some sentence like the marshmallows have oats in them. And then you're asking the model to predict whether this sentence is an entailment from the previous text or whether it's neutral, and so on and so forth. In this case, actually the model, which was a BERT-based model, predicted incorrectly that the sentence is entailment, whereas the target label is neutral. And the authors used this dataset called adversarial natural language inference, which comes with a human written explanation for why they think that the model made a mistake. And here they wrote, we don't know if they have oats in them or not, because there's no mention of the oats in the directions, but we know that there are oats in the dessert. This dataset that they're using comes up with about 20,000 of those examples. What the authors do is they try to quantify the importance of words in this article for coming up with the final correct output by doing some sort of alignment between the explanation provided by the human annotators and the article or the input provided to the model. And they come up with two models. One is the Oracle Importance hard mode, and the other one is the Oracle Importance soft mode. This is about the human scores of the importance of certain words in the document. Regarding the model importance, they are inputting these inputs to various transformer architectures like BERT, RoBERTa, and ELECTRA, and they're using a method called integrated gradients to measure the importance, the contribution of each token to come up with the final prediction. So this is somewhat similar to the attention, but a different approach which has shown to give a higher accuracy than the standard attention method, standard alignment, which you might have seen in some other papers. So they come up with these scores. Basically, you can think of some sort of a score for each word of how important it is. And then they try to correlate those scores with the hard or soft version of this Oracle Importance representing the human scores of the words. And basically, to sum up their main findings, there's three main findings. The first one was that surprisingly the BERT-base model had the highest alignment with the human-generated explanations, the highest correlation, higher than the more complicated RoBERTa and ELECTRA and so on architectures, suggesting that simpler models like BERT seem to be better if you were targeting higher alignment with human-generated explanations. Interestingly, also the base versions of all models such as BERT and RoBERTa and ELECTRA, the base models with fewer number of parameters had higher alignment with human-generated explanations than their larger counterparts, suggesting that increasing the number of parameters might not be the best approach if you specifically want to target alignment with human expectations. And finally, it seems that alignment with human explanations is not correlating with the accuracy of the models on this natural language inference task, suggesting that accuracy and alignment are not the same measures, but orthogonal measures, and probably both need to be considered separately when evaluating NLP models. So this is an interesting finding from this paper, leading to suggest that explanation or interpretability and predicting a correct label might be two different things. And actually, it's an interesting question whether you would like to necessarily have to have both high, or if you just focus on getting the correct output and that's okay. Or yeah, how to balance those two is an interesting problem, but this paper seems to suggest we may need to look into this in more detail if you want to build models that are not only producing outputs with high accuracy, but are also interpretable. It seems to be a complicated issue. So that is all that I wanted to cover from this paper. Please like and subscribe for some more upcoming NLP content.